All right, guys. So we finished one semester and we're starting this next semester. Now, rational functions is what we're going to be covering next, is the next new topic we're going to cover. But we're not going to get there today. What we're going to be covering today is factoring. Now, rational functions, well, rational is talking about fractions, because rational ratio are fractions. So when we talk about rational functions, we're going to be talking about fractional functions. Now, some of the functions that we can have as rational functions can be something like this here. This here is a rational function because we have variables, we have variable x, and it is in a fraction. Now, if I have two of these added together, what do I know about fractions that are being added together? The denominators have to be the same, yes? So we have to do stuff like this here. So this here is not bad, and there's ways that we can go about finding this, how to add these together. Now, the reason we're going over factoring is because, well, if I have, say, just x, no, not 2. We need to be able to make these here have the same denominator so that we can add them. But to do that, we have to factor this quadratic, so that we know what we need to have or what we need to have in order for the denominators to be the same. So one of the big things that's going to come with these rational functions, not just adding and subtracting, but it'll come with some multiplying, dividing, and our different operations, is we need to go back over factoring. Now, part of the reason I go back over factoring, because I do factoring each time before we do rational functions, so that it's fresh in our mind, because the last time we covered this, it was October, November. It's been a while. And we just come back from Christmas break. So this week, we're going back over factoring. So we're not jumping into rational functions yet. We're going to go back over factoring this week. So our first test is actually going to be over factoring, which will be next week. And that's what I want to go over today and this week, is just going back over greatest common factor, and factoring, so that we have it fresh in our mind again. So when we look at this first problem here, we're going to be factoring it. One of our first main steps that we're going to do when factoring anything is to see, is there a greatest common factor? Greatest common factor. That's what we should always be looking for. To see, is there a GCF, a greatest common factor? Now, when we look at this here, we do have three terms. We have 10x to the 7th minus 10x to the 4th plus 7x cubed. Right, there's not a number that's in common with all three. But there is something else that is. Because what do all three of these have? X. So we can factor out the variable x to the 3rd. Because they do all three terms have 3 x's. Is 10x to the 7, I can pull 3 of them out, yes? I can factor 3 out. The 4th, I can factor 3 out. The 7x to the 3rd, the most I can pull out of that one is 3. So that's why we stop at x to the 3rd, because that's the most we can pull out of all three terms. We can factor out of all three terms. So 10x to the 7th, well, the 10 stays the same. But we're pulling 3 x's out of x to the 7th. So x to the 4th. we'd have 10, because again, we didn't factor any numbers out. X. Because now we need to see if this would work out from here, but this is it. This is all we can do. Because if we were going to try to multiply these out, it wouldn't work out. This here is as far as it's going to factor for this one here. So for this problem and some of the ones on the homework assignment, it's just going to work out that some of them, one or two, just have a greatest common factor that we'd pull out. Well, for this one here, we don't have a second step. Because if it was factorable after we factored out the greatest common factor, then we would go into our other steps. And kind of part of the reason I know this, that this isn't factorable, is as we look at this here, because our biggest term is x to the fourth, yes? Well, what times itself is x to the fourth? Well, that would be either x times x to the third, or x squared times x squared, yes? And we saw this, it's been a while, but if I have x squared times x squared gives me x to the fourth, most likely somewhere here, I'm going to need these terms to show up. Because I'm going to either need an x squared somewhere, because if you remember, we had those middle terms added together. And because I don't have any x squared showing up anywhere in there, or x cubed, this ended up not factoring beyond this here. This is as far as it goes. So we can move on to the next one. So this here, so it could have 3 or whatnot. So this here just has 2, yes? Yep. Right, there's not an x squared term or an x cubed. There's no way that this can actually be broken apart in 2 sets. We can't write it as something like this here, because there's no way I can write 2 sets of terms multiplied together to get back to this here. It just doesn't go any further. Now this next one here, we do have 2 terms. Yes? We have 2 terms. We have an x and a y. So the variables aren't the same. So as we used to, because last semester where we wrote 2 sets of parentheses, found the signs, found the factors, well, we're not going to be able to do that. But is there a greatest common factor between these two? Is there a number that will go into 24 and 15? 3 will. If I factor 3 out of negative 24, or I divide 24 by 3, I'm left with negative 8y, because 24 divided by 3, or negative 24 divided by 3, will be negative 8. Then we'll do the same thing with positive 15. 15 divided by 3 would be plus 5x. And that's it, because there's no other terms between negative 8 and 5 that are in common that we can reduce. And that's all we have to do. And that's all we can do to simplify this down further. So there's a lot of terms here. And again, most likely, because these first few, we're just using greatest common factor again. Now when I look at all 3 terms, let's look at the numbers first. So we have 49, 28, 28, and 7. 7 can go into all 4 terms. Now we have u squared, and u. Is u in common with all 4 terms? Yeah, so we can also factor out a u. And that's it, because 7u does not have v, and 28u squared does not have a v term in them. We're not going to be able to factor that out. So that's as far as we can go with this here. Now, 49 divided by 7 would give me 7. Well, there's one u, and if I factor it out, I'm just left with v to the third. So 49 uv cubed, when I factor out 7u, leaves me with 7v cubed. Now, negative 28, if I factor out 7 or divide negative 28 by 7, I'm left with negative 4. U squared, if I factor 1u out, I'm left with just 1u. And we didn't do anything with v, so it'll be v squared. 28 divided by 7, this time it'll be positive 4. U squared factored out of u, I'm left with u. And 7u factored out of 7u would be just plus 1, because I factored everything out. Everything came out, so it'd be plus 1. And again, anytime we factor out everything from the term, so this here, 7u factored out completely, we have plus 1. Because when we use greatest common factor, we pull something out front, we factor it out. Whenever it's factored out completely, it's just going to be plus 1 or kind of minus 1 if it was negative. Doing this greatest common factor, we would never get 0 when factoring something out. And that's going to be it here. Because we don't have v all the way through, and that's about as far as we can go without making it more complicated than it already is. Without making it more complicated. Because we could factor out v squared from these two terms, but it's not going to make it any simpler. It's not going to make it any more reduced. We just have parentheses inside of parentheses. Yeah, we can only take it out of this here. The only way I would want to do that is if for some way we could end up having this as a set of parentheses, 2 sets of parentheses. But it's not, so we just leave it as this here. Because I'll show you what this would be, or kind of what it would look like, and it's not going to look like anything nice. It would look something like this here if we factor that out. But that didn't make it any simpler. It didn't make it any nicer to work with. But these two wouldn't work together. Mm-hmm. All right, let's look at one more of these here. So we do have a lot of letters here. But let's look at the numbers first. Well, I have 5 and negative 1. Even though there's not a number written there, the minus h squared j cubed k squared, it's 1. So for greatest common factors, well, 5 and negative 1, there's not one there. Well, I have h and h squared, so I do have a common term with h. And the highest power that I can pull out, the highest power I can factor out would be 1. Since I have, in the first term, I just have h to the first, the second one I have h squared. So the most I can pull out is 1. I can only pull 1 out of both terms. Now, we do have a j in common in both. I have j to the third and j to the third. So I can pull out all of them. I can pull out j to the third. First term we have k squared, the second term we have k squared, so we can pull out all of them. We can pull out 2 out of both. So really when we're using greatest common factor, we're trying to see which one, if it's in all 3 or in all the terms, which one has the lowest power, because that's the most we can pull out. Now we didn't do anything with 5, so it stays. So I pulled one h out of one h, so the h's is gone. They're gone. J to the third, I pulled out how many? 3, so they're gone. K squared, there's 2 k's, I pulled out 2, so the first term we're only left with 5. Minus, I have h squared, and we pulled out how many? 1, so I'm left with h. I have j to the third, and we pulled out 3, so it's gone. It factored out completely. K squared, well, we pulled out 2, so it factored out completely. So we're left with this here. Any questions on any of this here so far? Not too bad of a lesson to start back the semester with. Okay. Now we're getting back into factoring. So let me put the steps back up here. Now, first step, as we've been using, is our greatest common factor. Now, is there a greatest common factor between b squared, 12b, and 20? Well, there's a b for our first two terms, but 20 doesn't have a b. Now, we could look at a number, right? Because we have 12 and 20, they do have a common factor. But our b squared doesn't have a number with it besides, well, 1. And that's not a greatest common factor of 12 or 20. So between all three terms, we don't have a greatest common factor, do we? No. Okay. Now we're going to look at factoring. Well, we're going to have two sets of parentheses. With 3 spaces. So hopefully this is coming back. It might take a problem or two, but this is probably going to jump back into your head. 2 sets of parentheses with 3 spaces. Now the third step in this is finding the sign. If the signs are the same, if the sign of the constant term is positive, these signs are the same and they match the sign of the middle term. If the constant term is negative, the signs are opposite. You all remember doing this last semester? So we look at this here. Our constant term is, so the signs are the same and they are both plus and plus. So that was step number 3, and I didn't write it out here. Because our step 3 was finding these signs. We did that. Our fourth step is finding the terms, the factors of the first term and the third term. Now, b squared. The factors of b squared, the terms that multiply together to give me b squared, are, well, what? B and b. Because the only two things that multiply together to give me b squared are b and b. Those are the only factors of b squared. But we need to find the factors of 20. So I'm going to write these right here. So 1 times 20, 2 times 10. Well, 3 doesn't work. And then we have 4 times 5, yes? Well, the next number after 4 would be 5, yes? Is that listed already as a factor? So we're done. So when you're looking at factors kind of going down, I always start at 1 and increase on the left-hand side. And once the left-hand and right-hand side meet, they hit the center, because when they overlap, When I say overlap, the numbers on the left-hand side become bigger than the numbers on the right-hand side, then you're done. Because the factors would just start going the other direction. Does that make sense? So it's a way to kind of say, okay, we found them all. Now looking at this here, which one of these do we want to try first? 2 and 10. And our last step was to check, because if we're just doing factors, it's always good to check to make sure we have the right ones. And as we went over this the first time, I said we really don't multiply all the way through, because b times b, this here is going to give us b squared. So how did I find those first two terms? Well, they are the factors of what? B squared. So they should give me b squared, yes? Now 2 times 10 is 20. Well, how did I get 2 and 10? Well, they're the factors of 20. So those two terms should multiply together to give me 20, yes? Well, b times 10 is 2 times b is plus, which gives us and that's what we wanted. And that's it. That's all we have to do with this here. Any questions on any of this here so far? So hopefully, again, doing this again is kind of bringing it all back from what we did the first time. Any questions on this here before we move on to the next one? We good with this here? So this one here, we have a squared plus 4a minus 32. Is there a greatest common factor between all three terms? Well, no, because a squared doesn't have a number besides 1, and 32 doesn't have an a term. So there's not something in common in all three. So there's not going to be a greatest common factor here. So our next step is to have 2 sets of parentheses with 3 spaces. Now, if you want the steps listed out kind of all the way through, I will write them out and upload it to Google Classroom. So I'll upload that to Google Classroom later so that y'all can have those steps written out. Now, the next thing we're going to find is the sign. So step 1 was greatest common factor. 2 was our 2 sets of parentheses with 3 spaces. Our third step is to find the sign. Now, the first thing we look at is the sign of the constant term. And here the constant term is, so if the constant term is negative, the signs are opposite. One is going to be positive, one is going to be negative. Now, it doesn't really matter which one we make positive, which one we make negative. I'm just going to pick one positive, one negative, and we're just going to put them in. And our last step is really the reason it doesn't matter if we have one positive or one negative is because we're going to check it. We're going to check and make sure that we have the right setup. Now that brings us to step 4. Step 4 is the factors of the first and third term. Well, the factors of a squared are, well, a and a. A times a is going to give me a squared. There's no other way we can do that, because a times a is the only way we can actually have a squared. 32, on the other hand, is a little bit different. As well, we can have 1 times 2 times 16.
4 times 8.
5 doesn't work, and 6 won't work. And that's it. Well, we know 5 doesn't work because it doesn't end in a 5 or a 0. 6 doesn't work because 6 is a factor only if 2 and 3 are factors. If 2 and 3 are factors, then 6 will be also. And then 7, you just have to try, and it doesn't work. But these here are our 3 factors. Now, which ones do we want to try first? 4 and 8. So I'll just plug them in, 4 and 8. And now we can check it. So we're going to have a times negative 8, which will be negative 8a. Positive 4 times positive a is going to be plus 4a. And negative 8a plus 4a would be yes. But what do we notice here? We wanted what? Positive 4a, yes? And what did we get? We can switch the signs. Yes. Now for this problem here, because we have a and a, there's no numbers with the a. We don't have 2a and 4a or 2a and 3a. Switching the numbers and switching the signs for this one would do the same thing. But the better rule to have is if you get the correct middle term but the wrong sign, flip the signs. Because that way, if a is not just a in both spots, here and here, switching the sign will correct it. But switching the number might change it. Okay? So we switched the number, not numbers, we switched the signs. So this isn't right anymore. Now we have a times positive 8, which would give us positive 8a. Negative 4 times a would be negative 4a, which gives us 4a, which we wanted. And this here is the correct set of factors. Any questions on any of this here? Hopefully this is starting to come back for some of y'all. Hopefully it's making a little bit more sense the second time around, the third time around. Let's look at this one here. So this one here, we have x squared minus 17x plus 72. Well, there's not a greatest common factor between all 3 terms. So we're going to start off with our 2 sets of parentheses with 3 spaces. So step number 2. Step number 3 is going to be to find the signs. Now, since the constant term is positive, the signs are the same, and they match the sign of the middle term, which is what? It's negative, so both of these would be negative. Both of them are going to be negative. Any questions on any of this here so far? Okay. So that finishes up step 3. Now step number 4 is going to be the factors of the first and third terms. What are the factors of x squared? And x and x. Because the only things that multiply together to give me x squared are x and x. We only have one set of factors. Now 72, on the other hand, is not going to be as nice, because we're going to have 1 times 72. We're going to have several. We're going to have 2 and 36. We're going to have 3 and 24. Seven doesn't go into it. So looking at all of these here, which set of factors do we want to try? 8 and 9. Why don't we want to try 1 and 72? Oh, they're bigger than 17, yes? And the only way that we can make the middle term be smaller, or kind of the factors be smaller, is if the signs are opposite, yes? Because a positive and negative would make it smaller. But we know the signs are so most likely these terms are going to be combined and go straight up. So 8 and 9, I would agree, are going to work. Now if we check it, x times negative 9 would be negative 9x. Negative 8 times x is going to be negative 8x, which would give us negative 17x. And that's what we wanted, yes? So these here are the correct factors. Any questions on this here? Okay. X minus 8 plus 4. Or two sets of these parentheses? Yes, but you would have to have multiple variables. So, I mean, you could have like x minus y plus 3 times x plus y minus 4 as it, but that kind of factoring is very tedious to actually figure out and how it would work. Yes. And most of the time, whenever we factor these down, we can have more than two terms. Because, I mean, we did have some last semester where we had x squared minus 8x plus 3 times x plus 2. So it's possible to have it, but we were talking about higher degree polynomials. Okay. I'm going to skip over to this one here because I feel like y'all are getting pretty comfortable with these here. Yes, most of this is coming back. So we're going to skip over to number 9. So we're going to skip. So we skip to. So we're on the back of the third page, or probably the last page. There it is. So we have 4x squared minus 20x minus 56. So when we look at this here, is there a greatest common factor between all three terms? 4 will go into all three. So we can factor it out. So when I factor 4 out of 4x squared, I'm left with what? X squared, because 4 divided by 4 would give me 1. So I'm just left with x squared. Now, negative 20x, or if we factor 4 out of it, or negative 20x divided by 4, well, that would give me what? Negative 5x, because 20 divided by 4 would be 5. If I factor 4 out of negative 20, I get 5, negative 5, minus. Now we have to factor 4 out of negative 56, or 56 divided by 4 would give us what? 14. Write that a little better. So there was a greatest common factor of 4 this time. So we factored it out first. Now we can go back and look at this again and see, is there another greatest common factor? Because sometimes we can find a factor that's easy to see, but we might miss another one. So I'll look back at it again and see, well, okay, x squared minus 5x minus 14. Well, no, there's not another greatest common factor, is there? No. And sometimes when I look back, it's because we could see maybe 2, because it's easy to see that 4, 20, and 56 are divisible by 2. And if I did that, okay, well, I might see that there's another greatest common factor of 2, yes? That's the only reason I look at it twice, is it might be that there is a bigger greatest common factor I didn't see. But there's not. We found it. We found the greatest common factor. Okay. Our next step is two sets of parentheses. And I write these out because I'm assuming that this will factor. I'm assuming that it's going to factor. So that was step number 2. Step number 3 is to find the signs. Well, the constant term here is negative, so the signs are opposite. One is going to be positive, one's going to be negative. And that's step number 3. Now, step number 4 is to find the factors of the first and third term. Well, the factors of x squared are going to be what? X and x. Because the only two things that multiply together to give me x squared are x and x. Now, the factors of 14. We have 1 and 14 and 2 and 7. And that works out to be the only sets of factors. Now, which set of factors do we want to try first? 2 and 7. Which one do we want to make positive? 7 or 2? Make the 2 positive. And I agree with this here because we know the middle term is what? Negative. So we're trying to make the bigger number negative because here we need it to turn out negative. Well, here, so we'll do x times negative 7, which would be negative 7x. Positive 2 times x would be plus 2x. And negative 7x plus 2x would be negative 5x, which is what we wanted. Because again, here we wanted our middle term to be negative 5x. So this here is our answer. Now when we're checking it, we're looking back at the polynomial of what we're factored, or after we factor the greatest common factor out. We're not going to look back at this here, this middle term. Because it's not going to be 20 since we factored out the 4. That's going to be negative 5. That's the middle term we should get. Any questions on this here? Now, did factoring the 4 out really change what we did here? I mean, well, we factored it out, but these steps here for using the 2 sets of parentheses, finding the sign, factors of the first and third term, and then checking really didn't change, did they? No. It's going to be almost the exact same. So are there any questions on this here? Y'all need to see another one with the greatest common factor. We good with this here with the greatest common factor? Having one factoring it out? Yes? Okay.